Hi, hello. My name is Kiran Kumar. I'm your physics lecturer. Today topic is a dispersion of light through a prism. Welcome to my channel, Nature of Physics and Art. And before going to this video, please watch my previous videos based on the prism. Please try to understand step by step and please watch full video, then you can easily understand. Now, what is dispersion? Dispersion. See, when a white light passing through a prism, it split into its component colors. This phenomena is called dispersion. That constitute colors are VIBGR, violet, indigo, blue, green, yellow, orange and red color. Okay, so this is the white light which is incident on a prism. So it's split into VIBGR. See, here deviation angle of red color is less than to the deviation angle of violet color. More deviation angle for violet color, less deviation angle for the red color. See, this is the relation between the deviation angle and a refractive index of the prism. So that is del, which is equal to A of mu minus 1. Okay, see, from this relation, deviation angle is directly proportional to the refractive index. Okay, but according to the experiment, we got del V is greater than to the del R. Deviation angle of violet color is greater than to the deviation of the red color. Okay, according to the Cauchy law, that is experimentally a refractive index of a transparent medium depends on the wavelength of the light, and according to the Cauchy's equation, that is mu, which is equal to A plus B by lambda square plus C divided by lambda to the power of 4. Okay, here higher power lambda to the power of 4 is neglected and A, B, C are the constant and remaining value refractive index, which is equal to A plus B divided by lambda square. Here, try to understand from this equation, here mu is inversely proportional to the lambda square. Okay, so now we have mu is directly proportional to the lambda to the power of 2. Okay, already one relation we know very well, that is deviation angle is directly proportional to the refractive index. So here I am writing del A is directly proportional to the mu. From the both equation we can write here deviation angle is inversely proportional to the lambda square. Deviation angle is inversely proportional to the lambda square. So here more deviation angle and less wavelength. Less deviation angle, more wavelength. See now, experimentally we got deviation of the violet color is greater than to the deviation of the red color. That's why here wavelength of the red color is greater than to the wavelength of the violet color, because of deviation of violet color is greater than to the deviation of red color. Here deviation is inversely proportional to the square of the wavelength. Here we got relations based on the Cauchy equation. What is the Cauchy equation? Here refractive index of the prism is inversely proportional to the square of the wavelength. Try to understand from the relation Del is equal to A into mu minus 1. Here deviation angle is directly proportional to the refractive index. Nothing but here a refractive index, okay, and deviation angle relation. Based on this, here refractive index is directly proportional to the deviation angle. That's why deviation angle is inversely proportional to the square of the wavelength. Experimentally, the deviation of violet color is greater than to the red color, and according to the Cauchy equation, the wavelength of the red color is greater than to the wavelength of violet color. Please copy this. Now, angular dispersion. It is indicated letter theta. Okay, angular dispersion is defined as the difference between the deviation angle of violet color to the red color is called angular dispersion. In angular dispersion, we can consider the difference between the two deviation of the colors also is called angular dispersion. So we are considering here theta, which is equal to del V minus del R. So according to the definition, the difference between the violet color deviation to the red color deviation is called angular dispersion theta. Okay, so now del V, which is equal to A into mu V minus 1, and del R, which is equal to A into mu R minus 1. Here mu V is the refractive index of the violet color and mu R is the refractive index of the red color in a prism. Okay, so now we can replace these values in the above equation. The corresponding equation here, theta, which is equal to del V value is A into mu V minus 1 minus del R value is A into mu R minus 1. After solving this, we will get, okay, A into mu V minus mu R. So this is the equation for the angular dispersion. Theta is equal to A into mu V minus mu R. And please copy this. Now dispersion power, indicator letter omega. Dispersion power is defined as the ratio of angular displacement to the mean deviation. See now here omega, which is equal to the angular dispersion divided by mean deviation. Okay, so now we can write here omega, which is equal to angular dispersion is theta divided by mean deviation. Okay, so omega, which is equal to theta value is del V minus del R divided by mean deviation is yellow color. Okay, here the mean deviation is, that is del mean deviation we are considering as deviation of the violet color. Why we are considering yellow only instead of green color? Actually, middle color in a WebGR is G, green. But we are considering, that is deviation angle of the yellow color according to the wavelength in the WebGR. So here the wavelength of red color is more and the wavelength of violet color is less, and the wavelength of average color is yellow color. That's why del mean, which is taken as del y, that is deviation angle of the yellow color. Try to understand. Now we are writing here, that is omega, which is equal to, the values are del v minus del r, that is mu v minus mu r into a, divided by, that is deviation angle of yellow color, that is mu y minus 1 into a. Here a get cancelled, and omega, which is equal to mu v minus mu r divided by mu yellow minus 1. Mu yellow minus 1. Here we can write deviation angle of yellow color, which is equal to a into mu y minus 1. These are the relations for the dispersion power. When white light passing through the prism, it forms the VIBGR, in which a dispersion power is the ratio of the angular dispersion to the mean deviation, that is omega is equal theta divided by del mean deviation, that is omega, which is equal to del v minus del r whole divided by mean deviation is yellow color. Here del v minus del r value is mu v minus mu r into a, replaced here, and yellow color deviation is a into mu y minus 1, replacing here, a get cancelled. We got here angular dispersion omega is equal to mu v minus mu r divided by mu yellow minus 1. These are the relations for the dispersion power. Please copy this. Now, single prism. When light passing through the single prism, then light get deviation and dispersion. Both phenomena are takes place due to the single prism. Deviation del and dispersion, angular dispersion is theta. Okay, with the help of combination of the crown glass and front glass prism, with proper adjustment, we will get either deviation without dispersion or dispersion without deviation. We will discuss proof for the deviation without dispersion or dispersion without deviation in the next videos. Here just I am going to write equation, that is total dispersion and total deviation due to the combination of the flint glass prism and crown glass prism. Now here A is the angle of the crown prism and mu is the refractive index, and A dash is the angle of the flint prism and mu dash is the refractive index. One thing remember here, the A dash is angle of flint glass is opposite to the angle of the crown glass prism. Okay, so then we can write here total deviation. First one is total deviation. So that del, which is equal to del 1 plus del 2. Okay, so del, which is equal to del 1 is, we can write A into mu minus 1 plus del 2 value is A dash into mu dash minus 1. Try to understand from the given relation del is equal to A of mu minus 1. Here, deviation angle is directly proportional to the refractive index, and also the deviation angle is directly proportional to the angle of prism. Here, del 1 for the crown glass prism and del 2 is the flint glass prism deviations respectively. Okay, so now we can write now total dispersion, that is theta, which is equal to theta 1 plus theta 2. Okay, what is the basic value for the theta? That is mu v minus mu r into a. So for the first one, theta, which is equal to mu v minus mu r into a for the crown glass prism, and plus theta 2 is the flint glass prism, that is mu v dash minus mu r dash into a dash. This equation represents the total dispersion. Here, with proper adjustment of the crown glass and flint glass, we are getting deviation without dispersion, or dispersion without a deviation. Now we got total deviation, that is del is equal to del 1 plus del 2 for the first one and second one, and total dispersion theta 1 plus theta 2. These equations are very useful to solve the applications. Thank you very much.